Hello, all the PHP and technology enthusiasts. Today we will be talking about Observable Task Table, which is a Resonance PHP framework feature. And why does it exist? Good question. Imagine you have a service in which you are talking with some LLM or any external service, but in our case it will be llama.cpp server. And when I post something in chat, it is supposed to issue a request to llama.cpp server to get some tokens in response. But whoops, it doesn't work, we have an error. But luckily, we have a monitoring, we have observable task table. So how does this work? Let's restart our server. So we start with a clean state. I will issue a request again. It failed as expected. And now, what if I modify the code to issue 100 requests of the same type to a non-existent service? Let's restart everything again. We have 100 failed requests. Okay. So what will happen if I actually start llama.cpp? As you can see, llama.cpp server has some limited slots, some limited slot capacity to answer for requests. In this case, we have 8 open slots. So if I issue 100 requests, I expect most of them to fail, only several to pass. So let's try that again. Test. I don't know. We got some response. And as we can see, some tasks are finished, some are failed. Most are failed, as expected. And how does this work? We have to solve a few issues to get this to work, so I will dive into internals. So in general, how does Swool work to start with? So Swool is a standalone PHP library server that starts multiple worker processes to answer to user requests. And we should be able to issue the observable tasks. We should be able to observe them no matter what worker we are using. So no matter if request comes into the first one, the second one, the third one, or the last one, we should be able to observe them somewhere. So what do we need? We need a slice of a shared memory table. And this is where the slots come from. Because the shared memory has to be pre-allocated, it has to be already allocated when the server starts. So by default it's 10,000 slots for observable tasks. In each of those slots we can store task status and its metadata as shown here. So right now we have 100 occupied slots with its status, category, name, last update time, and how to use that in code. So observable task table is a framework feature, so it starts with your server. When server starts, it pre-allocates slots for observable tasks, and programmatically you need to use it as a service, observable task table service. I need to use observable task class, which is used to define the task itself and its metadata. Then it uses callback, which returns a generator that pushes status updates. So in this case, it pushes running update, then waits for 3 seconds, then pushes finished update. We can also add timeouts, and we do this by composition, not by extending the observable task. So we add iterable task, observable task timeout iterator, which is composed, which means is passed as an argument to observable task. And in this case, if any pause between status updates takes more than 5 seconds, the task will be cancelled. So this one won't be cancelled because it's running, then sleeps for 3 seconds, then finished. So we are okay. If you want to render task table like this one, you can do so really easily. All you need is some HTTP responder and some twig view HTML table. This table is iterable and you can slot statuses. And this is pretty much it. If you want to use this table, then enjoy. If you have any questions, feel free to join our Discord server. You can see it on Community tab or Telegram. If you really like what I'm talking about, you can also leave me a star, which would really help me. Thank you for being here and have a nice day.